Hi guys, welcome to today's SilverlightShow webinar. My name is Ralica and here with me is Gill Cleeren, our guest presenter who is going to discuss how Windows 8 applications can connect with services and the cloud to offer a great experience. For some background information on today's webinar topic, you can also check the new article series that Gill just started this week. It's titled Connecting Windows 8 Applications with Services, and part 1 is already available at silverlightshow.net, so you can check it out. So this session will continue for about 60 to 70 minutes, then we'll have a short Q&A at the end. So if you have any questions, you can address them using the chat option in your webinar panel. And Gill will try to answer as many questions as possible at the end of his presentation. And before we begin, I'd like to remind you that, as usual, we have ebook giveaways for tweeting this webinar using hashtag #WebinarSilverlightShow and for joining our post-webinar survey. So now let's move on to the presentation. Gill, shall we?
Okay. Thank you, Raleigh. Good evening, everyone, and welcome to this presentation, which, as Raleigh mentioned, is going to be about connecting Windows 8 applications with the outside world. So the goal is to show you as many ways of connecting a Windows 8 application with services, and also some other things where services are going to come into the view when talking about Windows 8 applications. Come on, my PowerPoint, there we go. So for the people who don't know me, so my name is Gill Cleeren. I work at Ordina as a .NET architect focusing on the XAML stack, so Silverlight, Windows Phone, and now also Windows 8. I'm a regional director and a Silverlight MVP, and I've written a couple of books on Silverlight. You can find my blog and my email as well as my Twitter on my on this particular slide here. So if you want to contact me, feel free to do so via one of these means. So this is my latest book that I've written, Silverlight 5 Data and Services Cookbook. Many of the things that are in here are going to be applicable on Windows 8 development as well. So in fact, many of the things that we're going to discuss today are a one-on-one match on the things that you could do in Silverlight and that are also explained in my book. As also mentioned by Raleigh, you can win by tweeting about this webinar by using the by filling in the post-webinar survey. So simply fill it in and you can get a three free ebooks from SilverlightShow. And you can also tweet about this webinar by and then win an ebook version of my latest Silverlight 5 book. You can ask questions through the Q&A window. We will try to answer as many as possible at the end of this talk. And if you don't have the time to spend with us the entire duration of this talk, a video recording is made, and the link for that video recording will be sent to you afterwards, so you can take a look at the entire webinar at your own pace afterwards. So let's take a look at what we're going to discuss during this talk. I'm going to first explain you a bit about the general idea of accessing data in a Windows 8 application. We're going to see where we can connect with data, how we can and how we cannot connect with data. I'm going to discuss a bit about using WCF as well as ASMX services in a Windows 8 application. We are going to discuss how we can connect with REST services as well. Those are more the general parts. Then we're going to dive into some more exotic types of services. We're going to look at OData. We're going to look at working with RSS feeds in a Windows 8 application. I'm also going to show you how you can authenticate with Twitter and Facebook using a class called the WebAuth Broker in Windows 8. I'm going to show you a bit about how you can connect with the Live SDK and with the Live Single Sign-On means also from a Windows 8 application. We're going to take a look at roaming data in your Windows 8 applications, and if we have time, we're going to take a look at sockets as well. There's one general point there, again, if we have time, that we'll take a look at. I'm going to explain you a bit about setting the correct capabilities for a Windows 8 application in terms of network communication. What I'm not going to be talking about, I found that important to put that in here as well, because you should know what else is out there. I'm not going to explain about the control channel trigger, which is a way of allowing your Windows 8 application to run under the lock screen and get incoming connections, or TCP connections basically, allowing the application to perform some actions based on that incoming stream. We also are not going to talk about raw notifications, which are notifications that can be pushed directly to the application. I'm not going to really discuss on how to connect from a Windows 8 application with Windows Azure. Finally, what I'm also not going to be talking about, but what I find important in this area, are background transfers and tile interactions. The reason I'm not going to talk about this is that we have already covered these in other webinars. So if you're interested in those, take a look at the other webinars I've done on Windows 8 on Silverlight and you'll find enough information to get working with background transfers and tile interactions. All right, let's get going. So first, I'm going to discuss the general topic, which is accessing data behind the service. Now, a Windows 8 application, in terms of accessing a data that is remotely being stored in a database, follows more or less the same rules as Silverlight. The Silverlight application could not directly connect to a database. A Windows 8 application cannot directly connect with a database either. So it's not possible to just enter, for example, a connection string in your configuration and let your Silverlight application, your Windows 8 application connect with a database. That would be a very high security risk, because remember, the Windows 8 application is going to be installed on the client through the store, but it is, of course, possible to reverse engineer that. And if you would store a connection string in your application, that would be a huge security risk. The second reason why that is not possible to do, well, the second reason is simple. There is no ADO.NET available in WinRT, so in the API to build Windows 8 applications. So it's therefore also not possible to actually do any direct communication with the database. For the people coming for Windows Phone 7.5 with the Mango release, there was a SQL CE database being added that is at this point not available in Windows 8. The second similarity that we have between a Windows 8 application and a Silverlight application is that server communication is done asynchronously. In Silverlight, this was done through the use of a callback in C#5, which can be used for Windows 8 applications. We have the ability to use the async await pattern, which allows us to await a call that is being done asynchronously to a service. It's much easier to develop that way. We have also covered that already in another webinar. The await async pattern makes it possible to write asynchronous code more or less in a synchronous way. So in general, connecting from a Windows 8 application to some data source is always going to be done through a service. There is no direct communication between a Silverlight application and a database possible. It is always going to be happening through a service layer that sits in between. Getting in the data is a three-step process: calling onto the service in an asynchronous way, awaiting the response, getting in the data, parsing the data, and then using it, for example, in a data binding scenario. This I've already said, I think. One thing to note here, some people might think, well, there is support for one type of database in a Windows 8 application, and it is a SQLite database. Tim Ewer has quite a few interesting blog posts on using SQLite from your Windows 8 application. That can be useful if you want to build up a local model, perhaps in an occasionally connected system. It might come in very handy to know that SQLite is supported. But we are going to be talking about connecting with services. And the types of services that Windows 8 applications can connect to is actually quite large. A Windows 8 application can communicate with an ASMX service, a WCF service, a REST service, an RSS service, or an RSS feed, sockets, OData services, and one thing that is notably missing is indeed, as you can read on the last line, WCF RIA services. There is no out-of-the-box support at this point, sadly, for WCF RIA services. That being said, you can expose your WCF RIA service that you may have written in the past to let it communicate with a Windows 8 to AtomPup, if I'm not mistaken. But there is no direct communication possible between WCF RIA services and Windows 8 applications. The same support that we got in Silverlight is not available at this point. All right, let's now dive in and let's take a look at how we can communicate with all these types of services. Let's first take a look at the very simple case, an ASMX service. An ASMX service, or also known as a really good old web service, is very easy to connect with from a Windows 8 application. There is no need to change anything on the server side to allow a Windows 8 application to communicate with an ASMX web service. Like any other types of services, the communication that is going to be done with an ASMX service from a Windows 8 app is of course asynchronous, and the communication is done through the use of a SOAP message. Connecting with an ASMX service is, again, the same as we did in Silverlight. We added a service reference, we let Visual Studio build up the proxy, and then we can use that proxy using the await async keywords. A very important thing to note here is that the proxy is different from what we had in Silverlight. In Silverlight we had asynchronous methods being generated. In Windows 8 those are task-based. Tasks can be awaited using the await keyword, and therefore all the code that is going to be generated in the proxy is also going to be task-based. Let's take a look at a demo where we are going to connect with a public ASMX service from Windows 8. Okay, so I'm going to use Visual Studio, and at this point it is still the RC. The funny thing is that at this very minute Windows 8, the RTM version, is released on MSDN. So, but it's actually quite risky for me to start using that from a live presentation. So I'm not going to do that. We are going to be using the RC version, and I had to open it via this way. Oh, there we go. It seems to be a bit messed up, but okay. So there we have the RC starting up, preparing the solution. This takes a bit longer than expected. Close this one down. Okay, that seems to take quite long actually. I think it's getting there. Just hold on, bear with me for just 1 minute. Maybe we should, if it's not coming up very quickly now, we should perhaps jump first to the next slides and then, it's coming up. There we go. So, let us take a look at what we need to do to connect from a Windows 8 application with an ASMX service. There we go. We finally have the service up and running. Let me move this a bit down. Okay. So, this is my very simple Windows 8 application, and I have connected with a public ASMX service. What I've done here is there's a public service as a weather service, and let's try clicking. There we go. Still quite slow. Let's try that again. There we go. So this is the public ASMX endpoint, as you can see here, and I have let Visual Studio create a service reference. That's the same as we did in Silverlight, adding the service address here, then allowing Visual Studio to create the proxy. Now let's take a look at the generated proxy code, and you can do that by opening this reference CS here. And notice we're not going to read this code because it's a generated code. But notice if we take a look at the generated code, it contains task-based methods. These task-based methods we can await in our in our C# code. So we have this public ASMX connected with. Now let's take a look at the code to actually perform the communication. Let's disable these two breakpoints. So I have an application and we're going to run it in just a second. Maybe we should already start the code and we can take a look at the code in the meantime. So what I've done here, I've instantiated the generated proxy by saying weather service client is a new weather service client. And then I've called onto the get city weather by zip async, and I've awaited that call. That was a task-based method. So all lines of code that are sitting below this await keyword are going to be waiting until the call comes back. The result is going to be a weather return, and once I have that, I'm going to be able to pass my response and use it in this case to show this particular string. There we go. There's a simulator. Put it on a lower resolution, perhaps. I think my machine is suffering a bit from the heat. We're having a heat wave over here, so I think my machine is overheating as well. Sorry for that. Okay, there we go. So I'm now going to call on to that public ASMX service, and I'm going to enter a zip code that I remember from my childhood, being a very popular TV program in the US, 90210, maybe you remember it as well. And we're going to call on to the load weather. It's taking a long time for it to execute. Still doing something. At some point we should get back the result. Okay, there we go. So now we see that in Beverly Hills it's actually quite sunny and the temperature is quite okay. So this is actually very simple to do. There's really no rocket science going on here in this Windows 8 application to connect with a public ASMX service. Now, an ASMX service is behind the scenes using the basic HTTP binding, and that it becomes important when we take a look at the communication between Windows 8 and a WCF service. Because most of the time today we're not going to build ASMX services, we're going to be building WCF services. Now what is supported in the area of WCF? The basic HTTP binding, which is actually the same one as we used with the ASMX service. The custom binding, which can be important, for example, if you've configured the server side to, for example, use a binary encoding. And then NetTCP and NetHTTP binding. So again, more or less the same story as in Silverlight. Again, the same story, for example, no WS-HTTP binding support in Windows 8. This is quite logical because the applications are going to be running on a client-side device. Therefore, it is not secure to actually expose private keys, which would be required for the WS-HTTP binding. That being said, security becomes a different problem, and we're going to take a look at securing the communication in the next couple of slides. You see here a list of binding elements that are supported. The other things that are supported: text binary encoding. Security, we're going to take a look at security in just a second. Credentials, transfer modes, serializers, the XML serializer, the data contract serializer, and the data contact JSON serializer are also supported. Again, more or less the same as ASMX. There is task-based methods going to be generated based on the proxy. One thing I haven't shown yet is the fact that no configuration code is going to be generated in the client-side Windows 8 application. If you come to think of it, it's actually quite logical that there isn't any configuration code. The real purpose of XML configuration code is allowing you to deploy the application and change some variables afterwards. Windows 8 apps are going to be deployed through a store, so there's no way for you to go out on the clients and change the configuration code. All the configuration code for services is going to be inside of a partial method inside of the proxy, which is called configure endpoint. If you have to do some changing of the configuration, you can do that through this endpoint. and configure endpoint method. Finally, also don't forget to specify the internet capability for the Windows 8 application. If you have time, we'll do that at the end as well, taking a look at the capabilities that we need to set. Okay, so let's take a look at accessing a WCF service from a Windows 8 application. I have here a very simple WCF service. As you can see here, this is the implementation. I actually wanted to open the contract. So this is my service contract. It's an image service that returns this list of picture IDs, and that is the operation contract. It will simply return me a list of IDs. The Windows 8 application has again a generated reference.cs. In that reference.cs, we again have task-based methods that are being generated. In the client-side code accessing WCF, you see that it's more or less the same thing, instantiating the proxy, calling onto the async method, awaiting the call, and then doing something with response. Notice, I hope you can see, I can't really zoom in on it. That doesn't really work well on Windows 8 while we do the webinar. There is no configuration code being generated. If you want to change anything in the configuration, we have to go into the reference.cs, so again in the proxy, and look for the configure endpoint method that you can see here, which is a partial method. If you want to change anything, you can do it via your own code, call onto this partial method, and pass the configuration from there. If you run the application again, accessing a WCF service, it's now calling onto that WCF service. I hope, there we go. It gets in some IDs and it shows me some pictures. All right, let's return to the slides very quickly. Now let's take a look at what happens in, or what we need to do, let's say, in terms of security. What if we want to secure the communication? The good news is that Microsoft has quite a few things in terms of security built into WinRT. For example, it is possible over WinRT to send credentials. If the service requires credentials, creating the proxy class will reflect that. So in here you see that this is code that was generated in the proxy that I copied here. The service asked basic authentication, basic HTTP security mode and using Windows credentials, and that is reflected in the generated proxy code. So it is possible to pass in credentials. That is, in this case, being sent in clear text over the wire. If you want a full-blown security model, you should be looking at custom validation, which is possible through the use of transport with message credential, which allows you to write any type of validation on the server side. Of course, then again, the credentials are sent in clear text over the line. If you want to make a better security, you should combine that with HTTPS, which allows securely which allows secure passing of username and password from the Windows 8 application to the service. Let's take a look at that. In the solution we have here, it seems that it's open 2 times. There we go. In the solution that we have here, I have this self-hosted SOAP service. You see here, and this self-hosted service requires basic HTTP binding. That's okay, and it also specifies that it needs Windows credentials to be passed to it. Now let's start by running this self-hosted service. Now let's go to the bin debug, because I have to run this as an administrator. Run as administrator. There we go. So now the service is self-hosted. I'm going to communicate with it from my Windows 8 application. Secure WCF. There we go. Let's simply type in some text. It's a service that requires some text. There we go. The response should be coming in. There we go. This was now done by first passing credentials. The service could check those credentials and only return a response if the credentials were passed okay. The client-side code, the code that we actually had to write, doesn't show any difference at all, as you can see. It just calling the service in an asynchronous manner. But if you take a look at the generated configuration code, in the generated code, so in the proxy code, you see here the same code as was in the slide. The service has said, well, I need transport credentials. Please pass me those credentials, the Windows credentials. So the service will actually ask to return those, and the client-generated proxy will reflect that. So that is automatically configured for us. This is what should normally, or would normally have been in your configuration, in your XML config or app config. This is now purely done in code. Now, what about REST services? We all know REST services. We all know the API that is exposed by Facebook, by Flickr, by Twitter. Many services are today REST services. Most of the public APIs are REST-based services. Also, we can build, using WCF, our own REST services. Also, the web API is also RESTful. So many types of services are becoming REST-based. Now, in Silverlight, this would have been accessed through the web client. In Windows 8, that is done through the use of the HTTP client, which is available in the system.NET namespace in Windows 8. It defines a get, a put, a post, a delete, all of course in an asynchronous way. So basically it is RESTful. It is purely RESTful, so you can communicate with a RESTful service from a Windows 8 application in a RESTful manner. The response, of course, is going to come in either in JSON or XML. If we want to use XML, we can use link to XML to parse it, the XML reader, or the XML serializer. If the response is coming in as JSON, we can use the data contract JSON serializer, or also use the JSON object to do parsing of the returned string. You can use the parse method on that. You can use the get named string or get named number to basically pass in a property, get back the value, or you can also use the indexer on the JSON object. That is not recommended. So in terms of working with REST, the story is very simple. Use instead of the web client, the HTTP client. For some reason, we get a pop-up here. I hope everything is okay. Raleigh, can you confirm that everything is okay?
Do I see the presentation?
Okay, good. Yeah, I got an error from the webinar software, but okay. So sorry for that. Let's continue by looking at working with a REST service. So let's open the accessing REST. There we go. In this, let's first run it very quickly. I've done this demo already in another webinar, so I'm not going to spend too much time. Let's search on Flickr. It's very easy to do that. I'm going to search for Brussels, which is a city here in Belgium, the capital actually. So we get in some response from Flickr. Flickr is actually sending me an XML-based response that I'm then parsing, and I'm downloading those images. Let's take a look at the code for this. For just as a small help, this is the code that we would have written in Silverlight. In Windows 8, we are going to use the HTTP client, on which I'm using the get async, passing in the URI, passing also in the API key. That is basically the entire URI that I'm going to send a request to. That call I'm going to await, and it is going to return me some HTTP response message that I am going to parse using the response content read as string async. I get the actual response, the XML. I put that inside of an X document and start doing some link to XML parsing code. Really nothing different going on, really simple to do, I think. Now, the same question might arise here. What about security in combination with REST services? If the REST service requires authentication, it is possible to do that via WinRT APIs. You saw perhaps that we used the client, an HTTP client handler in the previous example as well. I'm going to show it to you in just a second in more detail. So we can pass credentials to a REST-based endpoint. We can use the default credentials. However, in many cases, they are going to be a specific account, for example. So we can build up an HTTP client handler which has a credentials property which accepts a network credential instance, and that HTTP client handler I can then pass to my HTTP client allowing me to do the call passing in the credentials. All right, let's take a look at the next demo. Quite a lot of demos. So again, we have in that secure service here, we also have a REST-based endpoint, and that's what we have here. It's a web service host, therefore exposing the service as accessible over REST. I'm using the web HTTP binding, and I'm expecting Windows credentials to be passed. In the Windows 8 application, accessing secure REST, there we go. I am building up the HTTP client handler. In this case, I use default credentials, as you can see here, passing in the Windows credentials. If not, I could build up my own network credentials using username and password. And I could, of course, secure that using an HTTPS communication layer instead of just plain HTTP. And then I pass that handler to my HTTP client, which is then going to do the call using the get async. And it's really all possible using WinRT. So far we've covered, so far we've covered WCF, ASMX, and REST, and combining that with security. More or less, this covers like 80–90% of your ways or needs in terms of communicating with services from Windows 8 applications. Let's now spend the rest of this webinar, let's spend the next 45 minutes or so, by looking at some other types of services that Windows 8 applications can communicate with. The first thing we're going to take a look at is an OData service. For the people who are not familiar with OData, let me give you a very quick overview and a very quick refresher if it is some time ago that you worked with it. But what exactly is OData? It stands for the Open Data Protocol, and it's a way of simplifying how we connect with a service endpoint based on things that we already have, and those things are actually HTTP and the AtomPub protocol. We are going to expose a data model and allow clients to connect with that model, sending queries, getting an XML response. The problem that OData and the technique that is used for it, WCF data services, wants to solve is the following. Assume that we have some data model. We always end up with many service messages that we have to write. For example, let's say that we have a customers table. We write a get all customers. We have a get customer by ID. We have a get customer by name. A get customers by name ascending, descending. In the end, we end up with many service methods to query our model. The idea behind OData is simply saying we expose the model over a query-based syntax, allow the client to send in a query via the URI, and send back a response in XML. Let's take a look. A very good way of testing or of learning, let's say, OData is using the Netflix OData endpoint. Let me show you what it is. So I'm going to go to my browser. Let's open a new browser. There we go. And oops, there we go. So I've copied that link. So I'm now going to odatanetflix.com/catalog. So this is what Netflix does. They expose their catalog. They haven't written many service methods. No, they say, well, this is the model. You query it yourself. Let's do that. Let's go back to the slide. Let's say that we want to get, I could have typed it myself. Let's say that we ask for, give me all the jars. Right, there we go. So this is a list of jars now coming back from OData. It's quite a long list. So what I've done, I've queried the model and I've received an XML response. There is no service method. It's just the query, the request is sent via the URI, and we get back XML. That's the whole idea. And you can do a lot of things with OData. You can, for example, say, give me one specific genre, drill into that, give me the name, even do navigation. Give me all the genres, then give me the titles, or give me the links to other, give me the links property, I get the titles for that, and so on and so forth. So basically everything that you can do, not really everything, but most basic CRUD stuff, you can do it with OData endpoints. You can also do querying, for example, give me all the titles where the average rating is greater than 4. Or give me them descending, release here ascending, and so on and so forth. I think you get the idea. The idea is simply saying exposing the model via a query-based syntax and returning XML. Now the problem with that is that from the client perspective, you still have to build up those URIs and get back the response in XML. So it's more or less like replacing the problem is existing somewhere else, because now we have to build up the URIs and parse the XML. Therefore, for most technologies, including WinRT, there is a client library that does that for you, allowing you to write link-based queries and get back objects. And now since the RC, it is fully supported in WinRT. Before that, there were some issues. But since we are going to RTM very quickly now, let's not talk about the problems that we had in the past. Let's go to the next demo. Let's go to this one, OData. Let's take a look at this one. And I hope I have my database enabled. Should be enabled. Please, Visual Studio. Okay, there we go. So let's take a look at what we have here. So we have here a OData endpoint, this particular service, and that is exposing my model. And this is probably the most easy data model that you can have. It has just one table. And my OData endpoint is actually exposing that model. Sorry, this line of code is doing that. It's saying expose the user entity via the OData endpoint. And let's run this in a browser. And if everything goes well, we should see the response coming back. For example, let's say /users. And wasn't it users? Let me check if my database is running correctly. Could have been that my database service has stopped for some reason. It should be up and running. It should have been in capital. There we go. So now we are going to get a response. It is case sensitive, by the way. There we go. So now we get in the response. And so that is now the OData endpoint answering my query. Now, if I have to do that myself, again, I'm building up the URI, doing the XML parsing, still a lot of work. Instead, what we do is we use the OData client library. So I have a reference here to Microsoft Data, OData Metro, and Services Client Metro, which is the OData client library. And from then on, I don't have to build up all those things myself. It is done for me. For my code, it is much simpler. What I'm doing is I'm building up, of course I've added the service reference, by the way, I should mention that. And that service reference has generated for me an EDMX and a proxy class, basically. And in that proxy, there is a context. And it is, in this case, my CRM entities passing in the URI of the OData endpoint. Now I can query that. What I'm going to do is I'm going to say, dear context, give me all the users, order them by first name. Did you see me writing a URI? No. I simply wrote link code. And that is going to be translated for me into that query. And that is going to return me some XML. Let's run the application and we'll hit the breakpoints, which is good because I want to show you some things. I'm going to do load all users. There we go. The query has been built up. I hope you can read it. Again, I can't enlarge it. So it's going to go to localhost blah mycmdataservice.svc users order by first name. It has built that up based on the link query that I've written. Now it's going to do that asynchronously. It's calling onto that service. There we go. So I've built up the data service query. I say do that asynchronously, please. This call is going to be awaited. And then I'm going to put the results into a data service collection result, load in the data, and then set that as the item source for my list box. And so we should get some users in there in the UI. Great. So connecting with WCF data services, OData endpoints, is possible from Windows 8 apps. Perfect. Let's take a look at the next technology, and that is syndication over RSS. RSS, I think everyone knows that, real simple syndication. Exposing a feed, mostly from a blog, but other technologies use it as well. RSS is basically some XML, but it has it's basically always the same XML. It has a fixed schema. There is a post, an author, some data, some links, and some other elements. It is also extensible in some way, but the thing is, it's always the same XML. You can do the manual parsing. Why should you do that? Because in WinRT, more or less like the same in Silverlight and generally in .NET, there is a specific class or namespace available to do the parsing, namely the Windows Web Syndication namespace that contains two important classes, Syndication Feed and Syndication Client. What you have to do is you have to instantiate a syndication client, call on the retrieve feed async, and that will return you a syndication feed. And a syndication feed contains a list of entries that you can use in your application. You can parse them. The whole idea here is not having to parse the XML manually, but building an object model around the RSS result. Let's take a look at working with syndication feed. Let's take a look at the My RSS reader. I'll have all the samples available from SilverlightShow. There are some more samples in most of the folders, so you can take a look at them at your own pace. Okay, let's run the application first. I'm going to call onto a service, in fact an RSS endpoint. There we go. So this is the RSS feed that I'm going to download. That is being done asynchronously, and as you can see, there we go. We have the RSS feed being ready, and it's a Dutch feed, by the way, so might give you a chance to learn some Dutch while we go. So we have downloaded the list of entries in the syndication feed, and each item in that syndication feed has a title. That's the title. There's a link. There's some text, and these are some extensions on each post. Let's take a look at the code for this. It's very simple, in fact. So to start with, we have made a reference to the Windows Web Syndication. That's the first thing. Secondly, what I've done is I've instantiated the syndication client. I set the bypass cache on retrieve to true, which basically says that we're not going to use a cached response. Can also pass some request headers if needed. And then I'm going to call onto that client using the retrieve feed async, passing in the URI, and that gives me back a syndication feed instance. I'm going to use that syndication feed instance. It has an items property of syndication items, and that I'm going to use to actually build up my UI. In this case, there is no data binding used. It's all done old school, let's say. So I'm getting in an index on that syndication feeds items collection, and that gives me a syndication item. In that syndication item, I have several properties directly in the object model. So what I have here, I have the title, for example. I have the links for each syndication item. I have the extensions somewhere over here, the element extensions, which is also an iList. And then, of course, I have the actual post. A post can have both a summary and a content. I can have one, two, or either or both actually, and we can also. What I'm doing in this case, I'm putting that inside of a content web view, basically inside of a web view. I show that in my UI. So the whole idea behind passing RSS using the syndication feed classes is actually not having to pass them manually, but instead using an object model around it, making it much easier for you to work with. Now let's take a look at the web auth broker. Now, what I'm going to show you now is a way of authenticating to public services such as Facebook, such as Twitter, from a Windows 8 application using the web authentication broker. Now the problem, with applications such as Windows 8 applications, when they need to communicate with Twitter, with Facebook, previously the user had to enter username password, exposing that to the application. So it was basically the responsibility of the developer to make sure that those credentials were safe. Also, as an end user, you never knew what the developer was going to do with it. So the problem there was that there was really no nice, clean way to abstract the sign-in process from the real application. Now, many web apps today use authentication, OAuth. You may have seen that already. Twitter, for example, uses it for some years already. Some services like Flickr have completely switched over to OAuth. Previously, you could use a simple username password. It's not possible anymore. You have to use the web auth broker now. The authentication now. Now, the problem is that OAuth is not always easy to implement. The web auth broker makes it very easy for you to do the authentication with all kinds of services. It abstracts everything away from you. This is how it works. So when you say, well, now I need to authenticate with Twitter, with Facebook, whatever, the web auth broker will do an overlay over your app. That's what you see there, the calling app. It sits behind an overlay. There's a dialog area being shown in which a web page containing the authentication mechanism is going to be shown. So it's actually the website being shown in a separate process here where the user can do authentication. That will return to the application a token, a response basically, that the application can use to do subsequent requests. So in no in a single moment, the application will get access to the username password. It only gets the authentication token. And there's another benefit. If the user should change his username password, that token used by the application will keep on working. So it's actually the user granting the application access to the web API, so the Facebook API or Twitter API, but never at any given point does the application get access to the real credentials of the user, which is great. I think I've already said this, so let's move on to the demo. Save some time. So let's go to web auth broker. That's the one. Let's first take a look at Facebook. I'm going to do authentication with Facebook. I'm going to show you the code for this. Twitter is a bit more complicated, and I'm going to show you a shortcut for that. So let's first try authenticating the application with Facebook. So I need to first copy in some client a client message, basically, an application ID. Let's go back to the application. There we go. This is something that you get back when you register as an application developer. When you register this particular app, that's like your API key. And then we also have for Facebook a postback for this particular application. There we go. Go back here. I say now launch. So what will happen next is the web auth broker now creates the overlay, creates a separate application container where this particular process is running into, so no problems in terms of security. That launches a page that I as developer have to specify in my code where the user can then authenticate. So let's try authenticating. So that's gillcleeren@gmail.com. And let's now type in the password. So that should be it, if I haven't made a mistake. I'm going to log in. Boom. There we get the response. And there we get the access token. And the access token has a specific expiration date. But until then, that expiration date is basically the permission for me as a user for this application to do stuff with my Facebook application. Let's kill the app and let's take a look at the code. You'll be pleasantly surprised to see that it's quite easy to do. Of course, over here, there is. This is the URI that we have to do the authentication with, passing in the client ID. Then I use the Web Authentication Broker clause and call on to the authenticate async, passing in the URI that I want to authenticate with, also passing in the postback. Some applications require the postback. In my application, I'm not doing anything with it. We await that call. This launches the overlay, launches the separate process with the web page in there, and we get back a response in the form of the web authentication result. We can check if there was a success, if the logon was successful. If so, we can start passing the response to find, in this case, the authentication token. Now we can save that token locally, allowing us to do subsequent requests, even put it in application data, perhaps in roaming data even, so that the user doesn't always have to re-authenticate. Now, in terms of Twitter is more complicated. The logon for Twitter is in fact much more complicated. Requires a three-step process. What I recommend is take a look at some libraries. There is in fact one great library today out there on Codeplex, which is called TwitterRT, which is open source, of course, and it allows you to do authentication with Twitter by simply using one call. So in here, we are going to do gain access to Twitter. That is basically in the back launching the same web authentication broker, and then we can, once we log in, do an update status. I'm not going to go through through the code with you, because as you can see, I'm going to scroll very quickly. It is a bit more complicated than do the same thing with Facebook. Take a look at TwitterRT on Codeplex, or simply download the code here. It's actually very nice and very easy to work with. Okay. Let's move on. And let us take a look at the Live SDK. The Live SDK is more or less the same as using the Web Authentication Broker, but it has one major difference. Using the Live SDK, we can leverage, if the user has logged into his Windows 8 device using a Live ID, we can leverage SSO functionality. So single sign-on. The user will not be required to re-log in. You can simply use the credentials already used when logging into Windows. This requires, of course, if you want to develop something with it, the Live SDK 5.0 to be installed. I assume there's going to be an RTM version of that very quickly, and the application needs to be registered with Windows Live as well. Then what you can do is work with the content of Hotmail, which is now Outlook, Messenger, SkyDrive, all those things you can authenticate with, or you are already authenticated with, and you can leverage that inside of your applications. One thing that you have to remember is that the device has to be trusted. That's something new when you log into Windows with a Live ID. The device has to be trusted first before you can start doing anything. And that's what you see here. This device was not trusted yet at the time I made that screenshot. So it's not possible to actually get this thing to work then. How can we do the integration? Well, you can allow the user to sign in from your application. That will also pop up a window where the user can do authentication. You have to pass in scopes with something called the sign-in button, which is a control that you put inside of your XAML code. And the scopes are basically the permissions that you, as an application developer, ask from the end user. It's simply a list of permissions that you ask. Those will be translated inside of the window, allowing the user to decide whether or not he will allow your application to get access to his Windows 8. To his Windows Live information. Let's take a look at the demo. Let's open the Live SDK. I'm going to do some authentication. Let's open the demo very quickly. Okay. So the thing is, once it's authenticated, you cannot have it asked to re-authenticate. So you will not see any window here, but notice very quickly, here is a sign-in button, and now I'm signed in. Why has this happened? Because I put this button here on the UI, that's the live sign-in button, and I've passed in some scopes, which are the permissions that I've asked, and then I say session changed. And in that session changed, we're going to execute some code. So automatically, when I put that live sign-in button on my UI, my application is going to be able to log into Windows Live, allowing to do single sign-on. You didn't see me have to log in again. I did that authentication already. Normally, there would have been a window that asked me if I agreed with the permissions that this application asked. If so, everything is just fine. Those credentials are basically saved for the application, and the application can now do stuff with my Live ID. In this case, what we do is we get in the session, and so what happens here is, this is the session that we get in, the Live Connect session. Then we build up a Live Connect client, passing in the session, and then it gets a bit messy. The thing is, with the Live SDK, there's a lot of dynamic stuff going on, which is not always that easy to work with. In the Live SDK documentation, you can find those queries that you have to use, but they're all text-based. So on the next line, what you see here, Live client, so the Live Connect client, do we get async me? So that me is a string query, and that gives back a live operation result, on which I have to say result, and that gives me a dynamic. And on that dynamic, I can, for example, say the name, the locale, and a link to the Live ID, and that's what you see popping up here on the UI. There we go. Perfect. So it is possible to leverage that in your application, making your application more robust if you want to do stuff with SkyDrive and with single sign-on in general with Live SDK. Okay. Let's continue by taking a look at roaming data. Roaming data is not really a type of service that you connect with. It is the cloud built into your applications. Windows 8 and also the first party, so the Windows 8 Microsoft applications, leverage the fact of building a connected experience. What they mean by that is they say that you configure your application once on one device, those settings will be saved, and you can reuse them everywhere because they are automatically synced with the cloud to be used from everywhere. This makes it possible to give a better user experience to the user when he installs an application on one device, goes to another device where he has the same application. The cloud will make sure that the settings he has placed in one will automatically be synced to the other. That is a connected experience. Through the use of roaming data, Microsoft makes it possible for us as application developers to leverage that in our applications as well. Application data, we've covered application data in a previous webinar, is basically the local store for an application, has three options, local roaming or temporary. And the roaming is the most interesting one, because everything that you put in roaming data will automatically be synced to other devices. There are some big things, a few things to think of. What should you be putting in roaming data? Of course, not everything. it's basically setting stuff. For example, the user has set that in an RSS reader he wants to see 10 feeds on one page, saved it in the settings, making sure that he doesn't have to reconfigure that every time. Perhaps temporary document on which a user was working might also be a good idea. The level in a game, that's a great way of building a connected experience. I'm at home playing a game on my home PC. I shut the game down. Basically, I put it, I make it suspended. We as developers say, well, he's now in level 47. Let's sync that across all his devices using roaming data. Now I'm on the bus. I started the game again. I continue where I left off. State, context, all those things should be put in roaming data. You should not be putting things there that you should place normally in a local document directory or SkyDrive or Cloud Store. You should not be putting there a lot of things because it's also limited only to 100K, basically allowing you to make sure that the performance is still great. So how can you use this? Like I said on my RSS reader, how many items do I want to see on the screen? For example, 10. So I'm going to put in my roaming settings a key, items per page, and I set it to 10. If I want one specific item to be synced first, I can use name high priority, which will sync it as the first one. You can use more than one value as a composite value, which is basically a combination of more than one value. And you can also register for the data changed event. The data changed event will fire if the application is running on one device, the data was changed on another device, and then on that same device again, it's going to be firing data change, so that you as a developer can work with the fact that the data in the background is being synced with the application. It only works when you have a Microsoft account used to log into the device, which is actually quite logical. Otherwise, Microsoft wouldn't be able to sync the data. The device has to be trusted, the same as for the Live SDK. It is not to be used as a real syncing mechanism. In fact, if you sync too many times in a short time span, things will lock up because Microsoft will trouble the amount of syncs that you can do per specific amount of time. I'm not sure how many, but if you do too many syncs, it will actually block you for some specific amount of time. So it's not, for example, a good idea to build a movie player and say every second I'm going to update where the user is in the video or in the music file, because that would trigger too many syncs. Let's take a look at the code. Let's take a look at roaming data. There we go. So I'm going to write some simple data. So I wrote the setting, and I'm going to load in a simple data. There we go. So I'm going to have, this was the text I wrote, and this is the text I'm going to retrieve from roaming data. I'm going to show you the code at once. So in the write simple data, I use the roaming settings, which is actually declared as over here, and Windows storage application data current roaming settings. By the way, you have also local settings, which will not be synced. There's also a roaming folder to actually do syncing of real files. So settings is one way of doing it, files is another way. I can also use a composite value, which allows me to write more than one value in the same with the same key. So I'm going to load in the composite setting. So those are the two values that I wrote away with just one key. So let's take a look at that. Let's say create a composite setting. So I'm going to create a composite, which is an application data composite value, key, two values. And so then inside of this small dictionary, which is basically what it is, I'm going to put this particular value in this particular key. Afterwards, I can retrieve it. Load composite setting. There we go. So I'm going to load in the composite, passing in the composite key, and then in that composite, I again have a dictionary key value based. We can also use containers. A container is like a folder to organize your settings. And I really encourage you, I've done it personally as well already, to do grouping of your settings inside of a container, making it much more easy to, for example, delete every setting that has to do with one particular value that has to be cleared. So container is actually like a grouping. It's more like a folder for your settings. I can create a container, I can load data from a container as well. Okay, let's take a look at the code for the container. Writing to a container, create a container, there we go. So here I'm creating a container, and in that container I'm going to write a value. Sorry. And then here I'm going to test if we have a particular container using roaming settings containers contains a key. If so, I'm going to load in a specific value. All right. So that's it for roaming settings. And roaming settings is really an easy way to leverage the cloud inside of your applications without really accessing services to build it. Because if you would have to build that yourself, it would really be very complicated to get that to work, keeping in mind that there's a lot of syncing going on between several devices. The last type of communication that we're going to talk about is sockets. Now, sockets are always a bit magical, and not a lot of situations really require you to use sockets. However, in some cases, there is no other solution. The good news for us is that Windows 8 applications through WinRT have several ways of communicating with sockets. There's 5 different classes that are of importance here, which are the stream socket, the stream socket listener, the datagram socket, the message web socket, and the streams web socket. We are going to take a look at the stream socket listener, and the message web socket. The stream socket is the most easy one. It allows you to set up from your WinRT application a socket that other applications can connect to. Similarly, the stream socket listener is the other end of the communication, basically allowing you to listen for an incoming connection. So that's those two classes are going to be able to communicate with each other, the stream socket and the stream socket listener. Stream socket can be connected to, you can use for connection to build up connections. A stream socket listener you can use to listen for incoming connections. The datagram socket, if you want to, is important if you want to use UDP datagrams. We're not going to look at that one. And then the WebSocket classes, the message WebSocket and the stream WebSocket, are important if you want from your Windows 8 application to communicate with the with a WebSocket or a WebSocket that communicates with streams. Everything in this area lives in the Windows networking sockets namespace. Now, a good question might be, when do I use sockets? There are some specific cases when to use sockets. Generally speaking, I would say if there is a service layer that can communicate over HTTP available, don't go the socket way. Just use those proxies. Use REST, use an ASMX endpoint, use WCF endpoint. However, if there is none available, then sockets can be your last resort. For example, if you have to communicate with a service protocol that doesn't really, for which there is no real client-side library to connect with it available, sockets might be the only way of doing it. For example, if you need to communicate with an SMTP or a POP server, well, then sockets might be your only solution from WinRT application. If you need to connect directly with another app on the same network, then also you can use TCP. If you need to communicate with a WebSocket, then of course WebSockets might be the best solution. Let's take a look at TCP sockets. WinRT supports TCP and UDP sockets to be connected with and to connect from. As mentioned, living in the Windows networking sockets namespace, and there's 3 classes are important: the stream socket listener, and the datagram sockets. If you want to connect, if you want actually to connect from your Windows 8 application with some socket server, you can use the stream socket class. It allows you to create a TCP socket, use a connect async, passing in the address that you want to communicate with, and you can then do a bidirectional communication using the data writer and the data reader. advanced stuff, by the way. It is possible to use SSL as well here. I'm not going to go in that area. So the steps that you have to build, that you have to follow to build your stream socket are the following. You instantiate the stream socket. You can optionally use the stream socket control to give some more, to actually set some more properties on the stream socket. Use the connect async to build up the connection to the remote endpoint, and then have the output stream and the input stream, and use the data writer and the data reader to write on those streams. The close method can then be used to do the closing of the socket. If you want to listen for incoming connections, well, then you have to use the stream socket listener. Again, use the stream socket listener instantiated, and optionally use the stream socket listener control to set some specific properties. You can register for the connection received event to be notified when an incoming connection is being received. Then you can, once you have a connection received, use the bind service name async or the bind endpoint async to actually get in, to actually listen to a specific port or a specific service name. Once the connection is in, you have event args on which the socket is available, and you can use then again the stream socket, again with the output stream, input stream, to start writing and reading information. And again, you can use the close method. Let's take a look at this, because this is actually not very simple to do, and then we're going to finish up. I'm going to show you a sample from the SDK, which you can also download from Microsoft, of course. Let's take a look at the sample first running. Let's start it up. So this application is special in a sense that it will connect with itself. It has both a stream socket listener and a stream socket itself. So here we're going to start listening on port 22112. There we go. Now my stream socket is listening. I have a stream socket listener listening for incoming listeners. Incoming socket. Now I'm going to build the part that is going to send information to the stream socket itself. So again, on that same service name, connect, boom, there we go. Yeah, hitting a breakpoint here. So now I've connected, and now I can start sending data. So now the stream socket is going to send data, and the stream socket listener is going to accept data. Send data, boom. And so the information has been sent and has been received successfully. So it's a bidirectional communication. The good news about this sample is that it has both stream socket and a stream socket listener. Most apps will not have both. However, should you be building a peer-to-peer or a chat application, you might have both as well, because both can be a server and a client. Let's quickly take a look at the code, and then we'll finish off. So this is the stream socket listener. So a bit more at the top. There we go. So we have the stream socket listener being instantiated, and we listen for the connection received. Once the connection has been received, then this callback, the on connection, is going to be called. We ask for the data reader, and then we basically start waiting for incoming data. And because once we get the connection, we also want to wait for incoming data. Once the data has been received, we're going to say, first we're going to read the first 4 bytes, which is required to know how long the string is going to be. And then we're going to read out the string, and that is actually done over here. Dear reader, read me out the string. This is the length of the string that I want you to read out, giving me on the listening side the information that has been received. Now on the other side, sending data, have a stream socket over here. And then we say, stream socket, please connect with this particular host name and this particular port. Connect, please. Then the connection is made, triggering the on connection received over here, and then entering this particular loop, waiting for incoming data. And that only happens when we write data in the stream socket, and that's done over here. So when I clicked on that send hello button, I'm actually getting in the stream socket from the core application, which is like a global where we can store application-wide values. I get back my socket over here. On my socket, I use the data writer using the socket output stream to instantiate my writer. on the writer, I'm now going to write some data. And when I say store async, I'm actually going to push the data for my client, so for my listener to get in the data. And that is the end-to-end scenario working with sockets in a Windows 8 application, both from the client and the server. Okay, and we're not going to do WebSockets, so I think it's time to round up, Raleigh. So,
yes, thank you, Bill.
yeah, I'm going to quickly do the summary. Yeah. So, so Windows 8 is really capable in terms of types of services it can connect with. There's more or less the same as Silverlight. However, many things become actually easier. Seeing that we have the async await pattern to actually do the asynchronous development and not having to fall back on callbacks. There is support for security. There is support for authentication using the WebAuth broker. There was also support for WebSockets, which you haven't seen, but I think I've shown you most of the things that are really important in terms of connecting with services. I hope you enjoyed it. Let's now open it up for some questions.
Yeah, Joe, it's time for the Q&A session. So if some of the attendees have questions, they can send them. I have assigned a few questions to you.
Yeah, I'm going to try reading them. There we go. Okay, that's still a small window. There's a couple of questions. How to post images on Facebook. So yeah, if you want to post images on Facebook, it's going to be the same way as what we saw with the WebAuth broker. So the WebAuth broker is only during authentication. So the steps that you need to do then is do the authentication with the WebAuth broker, capture the token, which you saw coming back from the from the public, from the authentication page. That token I can then use to. Now that is annoying if Windows 8 messages start popping up. So what you can, sorry for that. So the OAuth token you save, and that is your permission for your application to do everything with Facebook, because the user has granted you access to do stuff. You do have to set up that, in your case, how to post images. You have to, I think there's a specific right on Facebook, I don't know if that is specific permission or not. If so, then you have to specify that, but it is enough to have that authentication token and then simply call onto the API that does the authentication, the image posting for you. Okay, so I hope that answers that question. Someone else asked here, if you want direct connection with a MySQL database, I would be interested in knowing how you would do it then, because it would make, I think you're gonna end up giving credentials in. Sorry for that. So the question is, how can we? Is it possible, basically, to connect with the MySQL database using sockets? I must say I'm not familiar with MySQL, but in terms of if I would do that with a SQL Server database, I think the story is going to be the same. I would be interested in talking to you, Miles, so maybe you can connect with me after the webinar via Twitter or via email. But as I see it, I don't think it's what you are asking is possible, because in that case also you would have to enter credentials in the client-side application, opening up a huge security risk. So I would advise against doing that. So I don't think that's possible. That's a good way. But I'm interested in talking to you about that. Is link to SQL CE or to a local database possible? Well, there isn't. So at this point, there is no SQL database, no SQL CE database supported, and also no link to SQL like we have in Windows Phone Mango. I hope I mentioned that while we during the webinar. As mentioned, there is support for SQLite, which has a link implementation, and there is a lot of interesting information on the blog of Tim Muir if you want to read more about that. There's another question about SSL that I really can't answer because that is not my cup of tea, so I'm sorry for that. Are there any other questions, Raleigh?
Now that's it with the questions. So thank you, Dio, for this presentation, and thanks for all who attended in this heat. If you have a few minutes, I invite you to fill in our short survey that will be displayed right after you exit the webinar. 3 of you can win an ebook of choice from SilverlightShow ebook market. You should know that a recording of this webinar as well as all demos and slides will be made available to you and emailed within a week. So thanks again for attending and have a nice rest of the day.